Okay, so a couple of things that we need to make sure we understand before we get too far with graphing inequalities. The first thing is, if it's a greater than or less than without the equal sign underneath, these are dotted lines, okay? Whereas these are solid. So if it has just a greater than or less than, it should be a dotted line. Now all these graphs, not all, if it's in this form y equals mx plus b, you should be able to do it by hand. I'll show you at the end how to use your calculator, but really you should be able to do all of these by hand. And you'll do a better job of drawing them on paper if you do. So remember, this b is the y-intercept. That's where it crosses the y-axis. So I start at 3 on the y-axis. Remember, this is your x-axis, this is your y-axis. So I put a 3 there. There's not a number in front of x, so that means there's an understood 1 over 1. So the slope on this is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You can follow that pattern for as long as you'd like. And now this is going to be dotted because it's just a greater than. Actually, it's a less than. So now, which values of y are smaller? So this line divides my graph in half. It divides it upper half and lower half. On which half are the values of y smaller? So y is less than. So these ones have smaller y values. So we're going to shade underneath. Now when you shade, since you're doing this with pencil, I'm going to show you as well. I want your lines to kind of go in the same direction. I don't want to see this and this and this. It makes it really hard to tell what's going on. So keep your lines going the same direction, and I'll explain why here in a moment. You're shading, you're graphing your answer really. So as you're doing this, this is the answer that you're drawing, okay? So that's the first graph. Now the next graph says y is greater than negative 3 halves x minus 2. So I go to negative 2, and I go down 3, 1, 2, 3 to the right, 2. Down 3 to the right, 2. So I could follow this same pattern and keep going. Okay? Again, these are going to be dotted lines, dashed. They are not solid. Okay? Now this says greater than, so we're going to shade above. Now, as I said before, I try to keep your lines all going the same direction. So these lines are all going this direction. Okay? Now this actually is the answer. You don't have to write anything on your paper, you're just shading. But the real answer is where these two graphs intersect. So that's why I wanted two different lines so that you can see, oh, these lines intersect in this area. Now if you really wanted to make it nice, you would make this part a little bit darker, so that I know for sure that you know that any point in this answer, in this area, is going to work. What I mean is, if I pick any point in here, so if I just randomly pick a point right there, that's 4, 5, 6, 6, 2. X is 6, Y is 2. If I plug that into here, then, so C6 plus 3 is 9, 2 is less than 9. It worked in this one. If I pick a point in here, 2 is greater than, 18 divided by 2 is negative 9. 2 is greater than negative 11. Any point in this shaded region is going to work if I plug it back in for both these inequalities. So any point, I could pick any one, and it's going to work for both of them. Okay, so that's what we're finding with two inequalities, is which points will work for both equations. So that's number one. Number two, now notice how I have 1, 2, 3, 4, 1, negative 1, negative 2, negative 3, negative 4. This is nice to have. You should have it on yours. So I can tell what you're counting by. So I know these little lines count by 1 or Are they counting by 2s or 3s or halves? What am I counting by? So you need to start putting that on your graphs. You need to start making your graphs look like a line if it's a line, and a curve if it's a curve. Okay, if it's a line, I shouldn't see this. Okay, if you want to draw a line, it should look somewhat like a line. So these are things that I realize I haven't taught you real well. I kind of maybe thought you had them in your knowledge banks, but after grading the quiz, I decided I need to do a better job of teaching you. So anyways, that's what I'm doing. Absolute value. Absolute value graphs are always going to be V. Here's the easiest way. This is the x coordinate, and this is how far it moves up or down. So if I go to this, and it's always opposite of the sign in here, I go left 3. Then that -1 means it moves down 1. That's the corner of my V, or the point of my V. Now this 2, I'm going to go up 2 and over 1, just like it's a slope. And I do the same over on this side. Okay. Since it's just a greater than, they're going to be dotted lines. Should you mess up and do a solid line and it's in pen, just write on the side of it, dotted line. That way I know you understand that it's supposed to be dotted and you get full credit. Now it says greater than, so if I look at these y values inside, they're bigger than the y values going down. So that means you're going to shade inside. Okay, so I'm going to shade inside of here. I wrote this over here on the side just so you could see how we could do this by hand. You should be able to do this pretty good. We haven't practiced a lot, but you should be able to figure out how to calculate a table. See where this arrow is pointing to the x? If you'll find what makes this go to 0, so -3 plus 3 makes this go to 0, that's the first number you're going to use. And then just go 2 below and 2 above. Now if I plug those in, I would have 2 times -3 plus 3 minus 1. So -3 plus 3 is 0, times 2 is still 0, minus 1 equals -1. And I would do that on every one of these. 2 times the absolute value of -4 plus 3. So -4 plus 3 is -1. The absolute value makes it positive. So 2 times 1 is 2, minus 1 is 1. Plug the 5 in. -5 plus 3 is -2, but the absolute value comes out positive. So 2 times 2 is 4, minus 1 is 3. So see how these are going up by 2's? My next one would be 5, and so forth. And these are going to be going down if we had a linear equation. But this is not a linear, it's an absolute value. So this is the change. So 2, now I'm going to plug -2 in. 3 minus 2 is 1, the absolute value of 1 is still 1. Times 2 is 2, minus 1 is 1. Oh look, they're matching. 2, -1 plus 3 minus 1. 3 minus 1 is 2. The absolute value of 2 is 2. 2 times 2 is 4. Minus 1 is 3. Oh look, another one. If I were to go 0, 2 times the absolute value of 0 plus 3. Absolute value of 0 plus 3 is 3. Times 2 is 6. Minus 1 is 5. So notice these match up. And see up on our graph, see how those are like matching up across here? So absolute values will always do this. They'll always be matching. Same thing with y equals x squared. Those will be matching when you make a table. They'll look almost identical to this, except for the absolute values will follow like a constant change. Change of 2, change of 2, change of 2. But anyways, that's more on absolute values. Now, -2/5 x plus 5 is a linear equation. It's y equals mx plus b. See, y equals mx plus b. B is 5, m is -2/5. So I go up here to 5, I put a dot. Now the -2/5 means I go down 2 and always to the right. So there's -2/5. Down 2, right 5. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4. 5. 1, 2, 1, 2, 3, 4, 5. Dotted line again. Now it says y is less than, so that's underneath. So I'm just going to draw my lines this way. As long as you draw them all the same way, I'm okay with it, okay? So if I look at this, the only place where my lines intersect is inside this triangle. So the only points that will make each of these inequalities true are the points shaded in that region, okay? So number 3, it's a parabola. So see again how I chose the point -1. -1 plus 1 would make 0, so that's why I chose -1. It's the one that will make this go to 0 inside of here. Now I choose 2 below. That's above. -2, -3, 0, 1. Okay, the other way, remember how I told you this moves the point, the vertex, left 1. It's always backwards of here. And then that moves it down 2. So I go left 1, down 2. Okay, now parabolas are a little bit different. So when I plug -1 in, plug -1 in for x, -1 plus 1 squared minus 2. 0 is what -1 plus 1 is. 0 squared is 0, minus 2 is -2. Now I plug -2 in there. -2 plus 1 is -1. Squared is 1. Minus 2 is -1. Now I plug 3 in there. -3 plus 1 is -2. If I go -2 times -2, I get 4 minus 2 is 2. Okay, just so you can see what -4 would look like. -4 plus 1 is -3. -3 times -3 is 9. That's the squared. Minus 2 is 7. So see, they don't have a constant change. Here it goes 1, 3. They do have 1, 3, 5. They always work like this. The next one would be 7. But anyways, parabolas are that way. Okay. Now if I told you on the absolute value that it's just the same down here. So realistically, you should be able to say, oh, it's going to be the same as these. Okay, you can see if you want to how that would work. 0 plus 1 is 1. 1 squared is still 1. Minus 2 is -1. 1 plus 1 is 2. So that's 2 inside of here. 2 squared is 4. Minus 2 is 2. Okay, so when I have -1, it's 1. -2 is 1. There's -1. At -3, it's up to 2. At 1, it's also up to 2. This is going to be a solid line because it's right there solid. 1, 2, 3, 4, 5. That one's the same. So that's what it looks like. Greater than, the y's inside of here are bigger than the y's down here. So that's going to be shaded inside of there. So I shade inside of there. Now this is a linear equation now. Y equals mx plus b. B is 3, m is -1. Even though they don't write it, it's -1 over 1. So I start at 3. I go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Same pattern continues up here. Okay, it's a solid line because it has an equal with it. I understand it's hard to connect your dots and make it look perfect, but it should be pretty close, okay? Now less than, the y value is less than, those are on smaller here. Up here, 4 is bigger than 2, so less than would be 2. So I'm going to shade below this line. So everything below that line. Now the intersection where these two graphs meet is this part right in here. Okay, so that's my answer. Now, question 4 is a circle. You probably don't know circles, so that's what I'm going to teach you. So the center of the circle is always opposite of these signs. This is the x, so it's opposite of the positive 3. This is the y, it's opposite of the negative 1. So I come to my graph, I go negative 3, positive 1. That's the center. Now to get the radius, you take the square root of this over here. So the square root of 4, what multiplies by itself to be 4 is 2. So that's the radius. So the radius is 2, so I just go 2 in each direction. 2 above, 2 below, and I go from the center. So I just go from the center, I go 2 each direction. And you try to make it a circle, okay? Now, unless you have a cheating tool like this, you're probably not going to get a perfect circle. So there's your perfect circle. So the center of this circle, the x value is negative 2, so that's going to be positive 2. The y value is a positive 3, so it's going to be negative 3. So x is 2, y is negative 3. That's the center. The square root of 16 is the radius, so the radius equals 4. So from this point I go 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, you try to make the circle as good as you can. Okay. If you have a little tool that allows you to do it, use your little tool that allows you to do it to make a good circle. If you got it lined up, then it makes a good circle. Anyways, there you go. So number 6, another circle. Opposite of the negative 3 is positive 3. Opposite of negative 1 is positive 1. X goes with x, y goes with y. So x3, 1. The square root of 9 is the radius, so that equals 3. So I go up 3, right 3, down 3, left 3. Okay? Draw your circle the best you can. So there's your next circle. Now this is an ellipse. It says it's an ellipse. Okay, they're a little bit different than circles. The center is the same. So the center is at 1, negative 2. Opposite of the x, opposite of the y. So right 1, down 2. There's my center. Now the difference on this is that we don't have a radius over here. Instead, we have these numbers underneath the x and underneath the y. So kind of like the radius, you take the square root of those. And that will tell you how far to go in the direction of whatever variable there underneath. So since the 4 is under the x, remember this is your x-axis, this is your y. In the x direction, left, right, you're going to go 4. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. The square root of 9 is 3, and that's under the y, so we're going to go up 3 and down 3. 1, 2, 3. So it's going to make kind of an egg shape. That's what an ellipse is. It's an oval. Okay. Again, you're just going to do the best you can, okay? And since it was less than or equal to, it's a solid line. I better check the others, make sure I didn't mess up on those. So those are all solid lines. Oh, I didn't shade the other ones. So back to question number 4, where it says less than 4. Here's an easy trick for you. Less than is inside. Okay. Greater than, everything outside. Okay. Less than, inside. And here's an easy way to check that that works. If I pick the center, which is at 3, 1, and I plug it in here, 3 minus 3 is 0. 1 minus 1 is 0. Is 0 less than or equal to 9? Yeah, 0 is less than 9. So that point worked. So everything that's inside the circle works. Okay. So number 7, it says it's less than 1. So less than would be inside. I can try it real fast. I can pick the point 1, 2, negative 2 for my y. 1 minus 1 is 0. Divided by 16 is still 0. Negative 2 plus 2 is 0. 0 squared is 0. Divided by 9 is 0. So I have 0 plus 0. Is that less than 1? Yep. So that works. Everything on the inside works. So I would shade everything on the inside of this ellipse. Okay, if you want to use colored markers or highlighters or colored pencils, go for it. Most markers are colored, by the way, so I was thinking colored pencils. But anyways, so this ellipse has a center at negative 2, negative 3. I threw a curveball at you. The x is here instead of at the front. So the x is negative 2, the y is negative 3. So negative 2, negative 3, that goes there. Square root of 4 is 2. So I go up 2 and down 2 because that's with the y. Square root of 9 is 3, so that's with my x. So I go right 3 and left 3. Again, it's a solid line because it's greater than or equal to. Make your egg, football, whatever you want this to be. Okay, greater than 1. So since it's greater than, I shade everything on the outside. Okay, so you just shade everything on the outside. If you want to take care of the holes that I've missed or whatever, you can. So the next one has 2 of them. It has an ellipse and a circle. So the ellipse, the center is going to be at negative 3, positive 2. So negative 3, positive 2. The square root of 4 is 2, and that's under my x's, so I go right 2 and left 2. Square root of 16 is 4, so I go up 4 and down 4. Now I draw my picture. Something like that. Okay. Since it's less than 1, we would shade on the inside. So everything on the inside gets shaded. That line wasn't supposed to go out of the inside. So now the circle, the center is at negative 3, positive 2. So it's opposite of those. So negative 3, positive 2. So negative 3, positive 2, same place. Square root of 9 is 3, so I go right 3, left 3, up 3, down 3, and draw a circle. Something like that. Okay, and it's greater than, so it's everything shaded outside of the circle. So all my lines go up and down, all those go sideways. So the only place that we're really worried about are where these intersect. So right in here and right down here. Okay, so that's the only place that we really worry about is this area. So anything that's in this area or anything that's in this area, that's the stuff that I'm worried about. That's the stuff that inside of this area, is my answer. Okay, that will make it true for both equations. If I pick any point in these areas, it'll make it true for both of those. Oh, that circle should have been dotted. So okay, so I realized that. So here's what I'm going to do. I'm going to put a little arrow there, and I'm going to put dotted, because that should have been a dotted line, right? Because it's just a greater than. So that's all you have to do if you mess up. Oh, that should have been dotted. Put a little arrow to it. That should be dotted. Now look at your paper when you turn it in. Oh, that's a dotted line. Okay, I understand they know what they're doing with it. Okay, number 10. So circle, positive 2, negative 1. So positive 2, negative 1. Square root of 4 is 2, so the radius is 2. It's going to be dotted. Okay, so there's my dotted circle. It says it's less than, so that's everything on the inside. Try to keep your lines all going the same direction, especially if you're using a pen or a pencil. That way I can see, oh, all those lines are going sideways. Your next lines are all going up and down. That's the intersection point or something like that. Okay, absolute value. So this has moved it right 2. The negative in front moves it so it's going down. So right 2, it's right here. There's really a 1 in front of here, so it's like I'm going down 1, right 1, down 1, right 1, down 1, right 1. And this line is also dotted. So anyways, this parabola should look like this. Okay, you can go to your calculator, type it in, y equals negative parentheses x minus 3 squared plus 1. Hit second graph. That'll generate the table. See, there's the 3, 1, 2, 0, 4, 0. So that generates the table. Okay, the other way to generate the table is to plug these values in. So if I plug 2 in for x, that's 2 minus 3 squared. 2 minus 3 is negative 1. Negative 1 times negative 1 is a positive 1, but then I put the negative in front. So that gives me a negative 1 plus 1, which makes 0. So that's why at 2 it's at 0. Okay, if I plug 1 in there, 1 minus 3 is negative 2. Negative 2 squared is positive 4, but then the negative comes in front and makes it a negative 4. So negative 4 plus 1 equals negative 3, so that's those. So if I were to do 6, I'd plug 6 in there. Negative 6 minus 3 squared plus 1. 6 minus 3 is 3. 3 squared is 9. The negative in front plus 1 makes negative 8. So 6, 4, 5, 6. So 6 is down here. That's my negative 8. And 0 is the same thing because it's symmetrical across there. So that's also negative 8. Or we can look at our calculator, and there it is, 0, negative 8, 6, negative 8. Okay? And it's a dotted line, and it's less than, so it's all shaded inside of here. Now for the last question, number 12, it's a parabola. So again, if you remember your tricks, this moves it left 1, down 3. So left 1, down 3. It opens upwards, but instead of going up 1, 3, 5, these are all doubled. So it goes up 2, 6, 10. So that goes 2, then 6, 1, 2, 3, 4, 5, 6. Okay, or I could plug these in. Whoops, not 0. needs to be negative 2, negative 3, 0, 1. So if I plug 1 in there, 1 plus 1 is 2. 2 squared is 4. Times 2 makes 8, minus 3 is 5. So that's when I plugged 1 in. So it's symmetrical, that should be 5. If I plug negative 1 in, I get 0. And 0 times 2 is still 0, minus 3 is negative 3. If I plug 0 in, 0 plus 1 is 1. 1 squared is 1, times 2 is 2, minus 3 is negative 1. Okay? Or you can go to your calculator. Y equals, clear, 2 parentheses, x plus 1 squared minus 3, second graph. There's my table. Okay? So I want to find where it's kind of seeing the symmetrical pattern here. There's my 5 numbers that I should plot so that I can draw my graph and make it look good. So there's my dots. It's a solid line. Connect your dots. Okay. If you have the dots, then I can see, oh, they're at least trying to get to this point, and I can see that you understand. Now it's greater than, so it should be shaded in here. Because the y values inside of here, 1, 2, 3, 4, 5, are bigger than these y values down here. So every y value inside of here is bigger than these y values down here. So that's where my y values are greater than.